Hi, today we're going to talk about file name expansion in Linux. If we know the file name exactly, we can look for it in the directory. However, sometimes we might forget the exact spelling. So we should be able to spell a portion of it and still be able to find it. That's where file name expansion will help. And also, sometimes we need to look for groups of files. Again, using the file name expansion syntax that we will learn, we can look for groups of files. The wildcard characters that we're going to learn about in order to use file name expansion are question mark, square brackets referred to as character class, and the star or the asterisk. So let's see how we're going to use these three types of wildcard characters to use file name expansion. Alright, so I'm in my directory called pmdir, and I'm going to list the files which exist in this directory. There's a whole bunch of files. If the simplest case is if I know the full name of the file. So let's say I'm looking for this file. I spell it out and it finds it. I'm looking for two files and I spell both of them out and it looks for it. Simple. But if I want to look for all files that begin with the letter P, have any other character after that, and end with a P, let's see what we get. We get 4 files. All of these are qualifying as a match. Why? Because they begin with the P, end with the P, and in the middle there is a 2 here, O here, underscore, and a dot. So you can see it does not matter what that character is. As long as there's one character, that's what one question mark represents here. If I said ls and put 3 question marks, I'm now going to get file names where the name is made up of 3 characters in total. If I said ls and put 1, 2, 3, 4, of course, these 2 come up because these 2 file names are made of 4 different characters. So one question mark holds the space for one character, any character. Let's say I want to look for files that begin with the letter P followed by any 4 characters. I get these files. However, if I want to narrow it down, in other words, I don't want the option of any character. I want to put restrictions on what character appears in the second position. That's where the second wildcard comes into play, which is a set of square brackets called character class. So in order to do that, I'm going to do an ls followed by P. Now instead of putting a question mark, I'm going to use a square bracket. And for the other 3 characters, I will continue to put any character. Now within the square brackets is where I'm going to put any restrictions. Whatever I put inside the square bracket are the choices for the matching. In other words, if I wanted only numbers to be allowed in the second spot, I can put 0-9, which means a range of numbers, all the numbers. So now when I hit enter, I only get the one file out of these 4 because P followed by a number only happens in this file name. This has a letter, this has a dot, this has a dot, so those will not qualify. Therefore, by using this character class here, I'm able to specify what is the restriction on the character in that position. Important to note that just like the question mark only represents one character, similarly, one set of square brackets represents only one character. The entire range here is just all different options. In other words, in the second position, I can have either a 0 or a 1 or a 2, etc., all the way up to 9, but only one out of those choices is allowed here for a match. Now the character class can be used in any spot. So for example, if I went look for everything beginning with the letter P, after that maybe I want 3 characters that are anything. However, I want to narrow down the last character or the 5th character here. Perhaps I'm looking for P, Q, R, S, or T. Those are my options. Now you see that I'm getting these 3 files. Why? Because it's P followed by any 3 characters, and then the last letter is a P. P followed by any 3 characters, and the last letter is a T. P followed by any 3 characters, dot being a valid character here, and the last letter is a T. That's why these 3 are qualifying. So you can see that the character class lets you put choices of what is going to be a match, what are you looking for, and it can be located anywhere within the file name. Now when we give choices which can also be represented by a range, then the syntax could also be represented in this manner. We can just go P-T, which means exactly the same thing because you're saying PQRST. So you can give a range or you can put specific options in detail. Now, sometimes you may want to say, I want everything but not P through T in this location. In other words, you want to reverse what this is saying. It's called negation. How do we do negation? We do negation by, let me actually bring this up. Now, if I put an exclamation mark here inside the square brackets, I'm saying do not allow this to be the match. So now you can see that I do not get the files I got before. I get a completely different file. Why? Because it matches P in the first location, 1, 2, 3. So dot, J, and P satisfy these 3 any character situation. And in the very end, it's saying in this last position, I do not want a P, Q, R, S, or T. And we have G, so it's not P, Q, R, S, or T. And that's why this qualifies. So character class, negation of the character class. Whatever choices you put here, if exclamation mark is the first character inside the square bracket, then all these will be disallowed as a choice. Within the square bracket, you can allow multiple types of characters. So in this case, I'm going to say find all files beginning with the letter P, and in the second position, allow any numbers or any lowercase letters, followed by a P again. So you can see that one set of square brackets holds position for one character, but the choices can be a multiple type of characters, numbers, lowercase, uppercase, etc. So far we've used the Filename Expansion syntax to locate files. So we've used it with the ls command, but we can also use it with any other commands where we are dealing with a group of files. For example, rm for remove, copy, move, and so on. So I'm just going to do one example with a copy command. First, if I show you what's in my subdirectory called D1, basically it only has one file called file1. So let's copy the files using this syntax. So these 2 files are going to get copied inside the D1 directory. So we're going to do a copy command, and when we need to indicate what are the existing files, we're going to say files beginning with the letter P, having 0 to 9 or A to Z in the second position and ending with a P. So that tells it which files to look for when you're doing a copy. So it's going to pick these files that match, and it's going to send it into the D1 directory, which is located in my current directory. So now, if I do the tree command again, I'm going to see that not only does it have file1, which it had before, but it also copied these 2 files because we said copy P followed by this criteria in the second spot followed by P. So it copies both of these files in this case. Same thing we can do with remove and with move. That brings us to the last special character or last wildcard character, which is the asterisk or the star. Now if I say ls, P followed by a star, I'm saying show me all files that begin with the letter P, and it doesn't matter what's after that. In fact, if you notice that one of the files it picked up has just the name is just the letter P, which is a valid name. So star or asterisk represents 0 or more characters. So in this case, it's 0 characters. In other words, P followed by nothing, followed by 0 characters. In this case, it's P followed by 3 characters, and so on. So 0 to many characters is what the star represents. If I said ls, P, followed by a number, and after the number I can have any number of characters. So now, because I'm specifying P, it looks for that. Then I'm specifying a number, it looks for that match. And then after that, it can be either nothing, which is the case here. So you've got P and one number, but nothing after that, because the star allows a match of 0 or more characters. We can also use it along with the question mark. So I could say ls, look for files beginning with the letter P, followed by any number, so 0 to 9. And after that, I want one character, which can be anything. But beyond that, I want 0 or more characters. So now we see these 3 files. So why didn't I get P2 here? Because with P2, it matches the P, 2 matches the number, but the question mark is requiring one more character to be present, right? Because question mark says one character must be present regardless of what that character is. This file doesn't have a third character. That's why this did not qualify. Why did this qualify? Because it has P, a number, and the letter P. And that's fine because the star or the asterisk allows 0 or more characters. So that gives you an idea of the 3 types of wildcard characters. Let me give you a couple more examples of that use all of these 3 wildcard characters. For example, if we look in the bin directory, which has a lot of the executables for the commands, if I do this, I'm now saying look inside the bin directory for 2 character file names. So all these already exist. I didn't create them. So what my ls command is doing is pointing to the bin directory, which already exists, and looking for only 2 character file names. So all of these here are just 2 character file names. I could repeat this command, and now I could say look for everything that has C at the end. So asterisk, which means 0 or more characters, but it must end in a C. So you notice that in the bin directory, anything that ends, any command which ends with a C, or any file name rather, which are the commands here, if they end in a C, those files are going to be picked up as a match. If I say ls sda star, and now this I'm going to look for in the dev directory, so it could be any directory you're looking at. In the dev directory, if I do this, I'm finding the hard drives. So SDA, SD1, SDA2, SDA3. I could use, instead of a star, I could say I want to look for a number, and that number is only 1, 2, or 3. So I can say this way, now I'm finding 1, 2, or 3. I didn't get this because I'm requiring that there be a number at the end of SDA. Because we already know we can specify individual numbers as well. Let me repeat this, but instead of a range, I can actually say 1, 2, or 3, and that's exactly the same thing it's going to find. Because we know that within a square bracket, we're really representing one character, and that one character can be either a 1 or a 2 or a 3 in this case. And we can use negation as the last example, where if we say find me everything that does not end in a 1, 2, or 3. Remember that one? So now it doesn't find anything because it doesn't have one that does not end in a 1, 2, or 3. Why didn't it pick up this one? Because SDA is matching, but the fact that we have a square bracket means it's requiring one more character here, right? And that character can be cannot be a 1, 2, or 3. SDA does not have another character at the end. That's why it didn't pick it up. So those are some of the examples that you've now learned for the wildcard characters, question mark, square brackets, and asterisk or star, where you can combine those to look for groups of files that match a certain criteria. Thank you.